guys, welcome to MoBileMaThS with Try. Today we are going to look at matrices 5. We are going to use matrices in solving simultaneous equations. So for example, I've got this equation that I have 4x minus 2y is equal to 9, and I've got another equation x plus y is equal to 3. So we are going to rewrite this simultaneous equation, taking the left hand numbers on their own and the right numbers on their own. So this is what we are going to do. We said we'll take the left ones on their own, the right ones on their own. Okay, so what happens when we are taking the numbers is like this. I'm going to take 4, 2, then on x, on the second equation, I've got a 1 here. This is the same as 1x, and on y it's the same as 1x. So I'll take 1 there, in such a way that if I'm to write a matrix equation, on the left I'll have 4, then I'll have minus 2. 2 has got this sign, so I'll have minus 2. Then on the bottom I'll have 1, and I'll have 1. Okay, then because on the left hand side we have got functions of x and y, on the left side it is going to form a 2 by 1 matrix. So we'll have x and y like that. Then that is equal to what is on the right side, 9 and 3 there, like this. Okay, so this is how we represent our problem from simultaneous equation to a matrix representation. Okay, now that we have written this in a matrix representation, what we are going to do is this. We are going to take the first matrix, this 2 by 2 matrix, and we are going to find its inverse. So we want to find the inverse of that 2 by 2 matrix. So we'll do what we have learned from previous lessons. Let's find the inverse of that. Okay, so let's find the inverse of 4, 1 minus 2, 1. Okay, so if we do that, we said we interchange the numbers. Interchanging will have 1 and 4 there. Then if we multiply by minus 1, so I've interchanged these numbers. That's where I have 4 and 1. Now after that, I now multiply by minus 1 on these ones, by minus 1 on these ones. Okay, like this. So if I do that, I'll get a 2 here, I'll get a minus 1 here. Okay, now with that being done, remember the A, B, C, D thing, and we said we get the inverse of 1 over AD minus BC. Okay, so we'll do that. So our A is 4, so we have 4 times our D is 1 minus B, that's minus 2 there, times our C, a 1 there. Okay, so if we multiply, what do we get? We'll get on the bottom we'll get, so I'm concentrating on this part there, I'll get a 6. We have a 4 minus 2. That's where I'm getting my 6. So the inverse of that thing, that matrix, the inverse of our matrix, 4, 1, 4, 1 minus 2, 1 is equal to 1 over 6, 1 minus 1, 2 and 4. That's the inverse there. Okay, so we are done with the inverse. That's how we find the inverse. Now we are done with the inverse. So what we do now, knowing that this is the inverse, we now take back our matrix with our simultaneous equation. We rewrite it as it was, together with our inverse. So I'll write 1 over 6 by 1 minus 1, 2, 4. Then I'll write the matrix that we had. We had 4 minus 2, 1, 1. And our operation xy is equal to 9, 3. Okay, so what happens is this. What we do on the left side, I've added this on the left side. I must also do the same on the right hand side, so that our mathematics is balanced. We have not violated or added anything. So I'll write that on the right hand side. Let's do that. Okay, so I'll have 1 over 6 by 1 minus 1, 2, 4, 4 minus 2, 1, 1, x, y. Then I have is equal to 1 over 6, 1 minus 1, 2, 4 by 9, 3, like that. Okay, so this is what we now do. We have added on the left side and done on the, added on the right side. This is on both sides. So what happens is this: whenever we have a multiplication of a matrix and its inverse, we get an identity matrix 1, 0, 0, 1. So this is what we'll get on that side, and we have here x, y. This will become equal to 1 over 6, 1 minus 1, 2, 4, 9, 3. Okay, like that. So now if we multiply an identity this side with xy, we will get xy, like that. You can prove that later on. So what we are now left is working on our right hand side. Let's work and solve on the right hand side. Okay, so we are now solving the right hand side. Let's solve the right hand side. So first of all, we have to identify whether the matrix is multipliable. Remember, we said this is a 2, this one is a 2 by 2 matrix. It's multiplying by a 2 by 1 matrix. So we can multiply because of that, and our answer is going to be 2 by 1 matrix. Okay, so we can multiply. Let's multiply. Okay, now we are multiplying. Okay, multiplying. So I have my xy on this side is equal to, I'll have my 1 over 6 outside and solve the brackets inside first. So I'll have row, the first row by column. So I'm still gonna use the row by column method, where I have row multiplying by this column, and I do the same for the next thing. Okay, so let's do that. Row by column, I have 1 times 9 plus 2 times 3. Okay, I don't have another column, so I'll go to the bottom one. I've got minus 1 times 9 plus 4 times 3. Okay, so this is what I have. Let's solve that. I'll get 1 over 6 by 1 times 9, I get 9, plus 2 by 3, I get 6. On the bottom, I've got 1 minus 9 there, plus 12. Okay, then solving that, let's not forget our x, y there. Solving that, I'll get 1 over 6 is equals to, I'll get 15 here. Then on the bottom, I've got 3. Okay, so that's what I have there. Now, because I've got 1 over 6 there outside, this is my scalar there. This is a scalar. I have to multiply it inside. So multiplying inside with our scalar, we'll get x over xy. Xy is equal to 1 over 6 times 15. I'll get 2, 5. Then 1 over 6 times 3, I'll get 0, 0.5. Okay, so this is how we have multiplied our scalar inside the matrix. Now, using that information, what happens is this. Because we have got an x on the upper top, it's going to correspond to the x into the 2.5 on the top, and our y on the bottom is going to correspond on y on the bottom. So x value is going to be 2.5, and our y value is equal to 0.5. If you want, you can go back to our equations and see if it holds. Let's see. The equation was saying we have got x plus y is equal to 3. Sorry, this is 5. This is 0, 0.5. 0, 0.5 here. I have written 8. It's 0, 0.5. Okay, so the first equation was saying x plus y there. Okay, like this. So let's do that. So if I do that, I have our x is 2.5 plus 0.5. Is it equal to 3? It's equal to 3. So this is true. Okay, this was a proof. I was proving this was a proof. Okay, so that's how we solve these problems. Okay, so here I've got some questions for you to practice. Please do these questions and solve them. Otherwise,